Yeah, welcome to day 6, people. There's a few, not so many people have done the survey so far, but I have to go out later, so I'm doing the videos now so that they're on there ready for you to review when you do get around to finishing the paper and having a look at the videos. It's good to see this question come up because we haven't had a binomial expansion question come up that's been tricky in the last papers so far. So I feel like we're getting good coverage at this point of the kinds of questions that could come up. I know that you guys so far have put down part 3 as being the hardest part, but I'm going to work through all of them again just so I get my head around this question as well. So we're going to find the coefficient of the x to the power of 8 term in that expansion. So I'm just going to write that out. So x plus 3x squared all to the power of 4. And that... How I like to get started with these kind of expansions is to start writing out the terms, just to remind myself what they look like. So when I start expanding that out, it's going to be, the first term is going to be 4c0, and I'm going to look at the formula sheet so that I don't get this formula and the binomial probability formula mixed up. So this formula works, that's going to be x is one of my terms, and 3x squared is the other term, and this is going to be the power of 4 there, and this is going to be to the power of 0 there. So that's the first term. What I'm after is the term that when you do this expansion comes out with an x to the power of 8 to it. So what you should be able to see is that when you do these expansions, you're going to be multiplying those two terms together to get your overall x term. In this case here, when you do something to the power of 0, it comes out to be 1. But let's say it was 4... Let's say it was 4c1, then that would be x to the power of 3, and that would be 3x squared to the power of 1. So when that part here was expanded, it would still be x squared, so all up, that would be x to the power of 5, right? So we need to find the right combination that will give us x to the power of 8. And hopefully you can see that that comes out to be this one here, so x to the power of 0 and 3x squared to the power of 4. The only tricky thing about this, 4c4 is 1, x to the power of 0 is 1, is remember that's everything inside the bracket is to the power of 4, so it's 3 to the power of 4 as well as x squared to the power of 4. So 3 to the power of 4 is 81. And obviously x squared to the power of 4 is x to the power of 8. So the answer they were after is just the coefficient, which is 81. Okay, and so now for the next part, it's similar, except now we're dealing with a power of 5 overall. But the same deal as we're trying to find the coefficient of whatever term comes out to be x to the power of 8. So if we go back over to our diagram over here, I'm going to go and just change some numbers on this. So we're now dealing with 5c0, and this first term would be to the power of a 0, which means the second term would be to the power of a 5, and so forth. So that would be 5c1, that would be a 4, that would still be a 1, that would be 5c4, which means that would be 5c5, that would be a 0, and that would be a 5. Just a few terms really quickly, and I can do that because I've got this application. Obviously you wouldn't necessarily have to write them out. If you can spot the pattern already, to find out how you're going to get basically this times this plus this, or this times this plus this to equal 8. So you can see that this is too far. 2 times 5 is 10, that's too far. Here we've got 2 plus 4, 6, that's too small. And so after a bit of sort of checking, you should be able to get the answer, which is 5c3. So x is squared, and 3x squared is to the power of 3. So that all works out fine. Those two powers add to 5, which is how it should be. This is the same as the second power, which is what the formula tells us it's supposed to be. 2 times 3 is 6. X squared, so that's a power of 2, and 6 plus 2 is 8. So we've found the right place to find our coefficient for the x squared term. So if we go ahead and work that out, 5 C3 is 10. Obviously we've got x squared over there and x to the power of 6 over there, which is x to the power of 8. But don't forget that it's 3 to the power of 3. So everything inside that bracket is raised to the power of 3. So 3 to the power of 3 is 27. So that's times by 27. So we get 270 x to the power of 8. You don't need the x to the power of 8 because they are just asking for the coefficient, but there's no harm in writing it out. Okay, and on to part 3, which probably looks quite scary, but actually it's unbelievably easy. Just wait, you'll see. So it says hence, and that hence is a clue that tells you that you have to use your answers from part 1 and part 2 to solve part 3. So watch out for that word. And they want us to look at the same thing, the coefficient of x to the power of 8, but for this like way looking crazy, scary expansion that probably freaked you out when you saw it. But remember, we have to be able to do this. Everything that they assess us on in the exam has to be what we've learned. So, okay, it's a bit a little scary, but I'm going to do what I showed you before. I'm going to start laying out what the terms would be when I start to expand it. So when I look at this, you can actually still look at this like a binomial expansion where this is one term and this is the other term. Okay, so if I was to start to expand this out, the first term would be 5c0, and then it would be 1 to the power of 5, and it would be all of that, x plus 3x squared, all to the power of 0. Right, and my next term would be 5c1, 1 to the power of 4, and then x plus 3x squared, all to the power of 1, and so forth. And so what you can see after just, doing a little bit of initial examination of the problem is that, in fact, what you end up with in your expansion is 1 to the power of 5, or 1 to the power of 4, 1 to the power of 3, and none of that will make a difference to your answer because 1 to the power of anything will be 1. And then you get these familiar-looking expansions which look like these ones here, except obviously I've just started the first few terms, so I haven't quite got to the power of 4, power of 5 yet. And so when you were to do this expansion properly, all that would happen is that you've got like an expansion with an expansion to work it out. And what we know is, first, we know that this doesn't make a difference. The coefficient at the front does make a difference. I should use a different colour for that. So I use white. But this 1 to the power of whatever is not going to make a difference. And that, of course, would need to expand again using the same sort of rules. So, for example, if I was to expand that out, it's x plus 3x squared to the power of 2. So within that would be 2c0 plus, times x to the power of 2 times x plus 3x squared to the power of 0, and so forth. Would all be sitting, that whole expansion would all be sitting inside this expansion here. Okay. The main thing here, though, is that I don't actually have to do any more work. I have already worked out for part 1 and part 2 that when I have x plus 3x squared to the power of 4, that my the coefficient of the x to the power of 8 term is 81, and I've already worked out that when 3x plus 2 is to the power of 5, that the coefficient of my x term is x to the power of 8. So all I have to do is go back to this expansion here and think, when would I get the power of 4 and the power of 5 in that expansion? And I get that right towards the end. So when I had 5c1, I would get, 5c4, I would get 1 to the power of 1, and I would get x plus 3x squared to the power of 4, and then I'd also have 5c5 right at the end, it'd be 1 to the power of 0, and x plus 3x squared to the power of 5. Okay, so now I would get those two terms, which is what I've already worked before, which is how we're going to recycle our answers like they've asked with the word hence. So all I do here is I already know which, when I expand this out, that those are the terms I'm after. So what I can do, I don't care about any of the other terms, I can just replace that with 81x to the power of 8. I've already done the hard work of finding out what the coefficient is of the x to the power of 8 coefficient in that expansion. And the same thing here as well, I can replace that with 270x to the power of 8. 1 to the power of 1 is just 1, 1 to the power of 0 is just 1, 5c5 is just 1, and 5c4 is 5. So what I do is I'm saying, right, for this expansion here, the total coefficient of x to the power of 8 would be 5 times 81. And for this expansion here, the total coefficient would just be 270. So if I did the whole massive big expansion, I'd group up all the like terms, I'd get 5 times 81, and I'd get 270, I'd add them up all together, and I would get 675. And that's the answer there.